Let's take a look at our practice test. We're told to solve each equation, and for problem number 1, we have the absolute value of x plus 6 is set equal to 1. Now for this type of equation, the first thing we want to do is isolate the absolute value operation on one side of the equation and then have a single number on the other. So in this particular case, we already have that. We have the absolute value of x plus 6 isolated on the left, and we have this 1 that's isolated on the right. Okay, so from here, what do you do? Well, basically, you're going to take the expression inside of the absolute value bars, and you're going to write that. So we'd have x plus 6. And in the first scenario, you just set it equal to this number over here. So it equals 1. So basically, just drop the absolute value bars. Then we're going to write our keyword or, because we're going to be setting up a compound equation with the keyword or. And then the next one, I'm going to drop the absolute value bars again. So I'm just going to take that expression and put x plus 6. But now I'm going to set it equal to the negative of this number over here. So in this case, this would be negative 1. So what I want to do is solve these two equations. And let's go ahead and do that real quick. On the left, I'm just going to subtract 6 away from each side. And so this is going to cancel here. And what I'm going to have is that x is equal to negative 5. Then I'm going to put or. On the right over here, I'm just going to subtract 6 away from each side. And again, this is going to cancel. So what I'll have here is that x is going to be equal to negative 1 plus negative 6 is going to be negative 7. So x could be negative 5 or x could be negative 7. Now, as I talked about in the lesson, there are a lot of ways to notate your solution for this. You could keep it like this if you want. You could write it like this. You could say x is equal to negative 7 comma negative 5. And then you could also use your solution set notation. So you could say negative 7 comma negative 5 inside of your set braces. Again, just get with your teacher in terms of what they want you to do. If you're self-studying, I tend to like this one, but it's really up to you. Okay, I want to check this one with you just so you get an idea of what's going on here. So let's go ahead and write this absolute value of x plus 6 is equal to 1 like this. And in the first scenario, let's choose negative 7. So let's choose negative 7, and let's see what's going on. So negative 7 plus 6 is going to give me negative 1. So I have the absolute value of negative 1 is equal to 1. Now notice that this number does not exactly match this number. But what's going to happen is the absolute value operation is going to fix that for us, because the absolute value operation is going to change negative 1 into positive 1, and so the left and the right side are going to be equal. So this would be 1 equals 1, so this works as a solution, right? Again, because of the concept of absolute value. So let's erase this, and let's erase this, and now if we put negative 5 in there, well, negative 5 plus 6 is positive 1, and the absolute value of positive 1 is 1, so you get 1 equals 1, so this works as a solution as well. Okay, let's look at problem number 2. So here we have the absolute value of x plus 2, and this is set equal to 8. So let's go ahead and say that we have x plus 2 is equal to 8, and then or we'll have x plus 2 is equal to negative 8. Again, we'll just solve these two equations. So I'll just subtract 2 away from each side of the equation here. That'll cancel. And what I'll have is that x is equal to positive 6. Then or, over here, let's subtract 2 away from each side of the equation. And let's say that x is equal to negative 8 minus 2 is going to give me negative 10. So basically, x can be 6 or x can be negative 10. Again, if you check this, 6 plus 2 is 8, positive 8. The absolute value of 8 is 8. Then if you put this one in, negative 10 plus 2 is going to give me negative 8. The absolute value of negative 8 is 8, so 8 equals 8. So both will work as a solution. Again, if you want to write this like this, I'll say x is equal to negative 10, comma 6. Okay, let's look at problem number 3. So this one's a little bit different in terms of the setup. Let's slide down here a little bit. So we have the absolute value of 9x plus 9 is equal to the absolute value of 2x minus 6. So two numbers or two expressions can only have the same absolute value if they're equal to each other or if they're opposites. So I could do something like the absolute value of 3 is equal to the absolute value of 3. This is 3 equals 3. Or I could do the absolute value of negative 3 is equal to the absolute value of positive 3, right? Those would be equal because this guy is going to flip to 3. This guy would stay to 3. So either way, you get 3 equals 3. So I'm going to use that same concept here and just say that in one scenario, I could just drop the absolute value bars. So I could say 9x plus 9 is equal to 2x minus 6. Then or the other scenario is I would basically drop the absolute value bars. So let's go 9x plus 9 is equal to 2x minus 6. And I've got to pick one of these. It doesn't matter which one. And I've got to apply a negative to the whole thing. So wrap it in parentheses and put a negative out in front. It can't be that you just put a negative to one of the terms. You've got to wrap it in parentheses and apply the negative to the whole thing because I want the negative of this expression. So I'm going to subtract 9 away from each side of the equation, and I'm going to subtract 2x away from each side of the equation. Let me slide this keyword or down a little bit so we have a little room to work. So I'm going to cancel this and cancel this. So 9x minus 2x is going to give me 7x. And this equals negative 6 minus 9 would give me negative 15. We can divide each side here by 7. And I'll say that this is going to cancel. X is equal to negative 15 sevenths. Over here, I'm going to apply this negative to each term inside the parentheses. So I'll have negative 9x and then minus 9. This equals 2x minus 6. Let's add 9 to both sides of the equation. And then let's subtract 2x away from each side of the equation. So let's cancel this and cancel this. And let's say that we have negative 9x minus 2x, that's negative 11x. And this will be equal to negative 6 plus 9 is going to be positive 3. And let's divide each side of the equation by negative 11. And so what we'll get is that x is equal to negative 3/11. Okay, so coming back up here, I just erase everything so it would be nice and clean. I'm just going to write the solution as x is equal to negative 15 sevenths. And then also you have negative 3/11. Again, if you want to use the keyword or, you can. I'll let you pause the video on your own and check each of these as a solution for the original equation. You'll see that they both work. Okay, let's look at problem number 4. Same setup as problem number 3. So basically I would want to drop the absolute value bars to start. So I'll have 4 minus 7x is equal to, you'll have negative x and then plus 4. Then you're going to have or. So let me write or. So then you're going to drop the absolute value bar. So 4 minus 7x is equal to negative x plus 4. And then you've got to pick one of these guys. Let's just do this one on the right this time. And you've got to wrap it in parentheses and just put a negative out in front. Let me slide this out of the way. We'll get to this later on. I'm just going to solve this one first, and then we'll slide down. So for this one, let's add x to both sides of the equation. And let's subtract 4 away from each side of the equation. So this is going to cancel, and this is going to cancel. So we can already see that x is going to be 0, but let's just continue. So this is going to cancel over here completely. So on the right, I just have 0. On the left, I have negative 7x plus x. That is going to give me negative 6x. Divide both sides by negative 6. And like I just said, x is going to be 0. So this cancels. And we'll put this over here, or I can just write it here. So x is equal to 0 divided by negative 6 is 0. So let me just write up here, x equals 0. We'll come back up to this. We'll add on to that solution in a moment. Okay, so let me start by just writing the left side. 4 minus 7x is equal to, on the right side, I'm going to apply this negative to each term inside the parentheses. So the negative of negative x is x, right? I'm just changing the sign from negative to positive, and this becomes negative. Right, again, just changing the sign. So from here, let's subtract x away from each side of the equation. So this is going to cancel. And then let's subtract 4 away from each side of the equation. So this guy right here is going to cancel. So negative 7x minus x would be negative 8x. And this is equal to negative 4 minus 4 would be negative 8. Let's divide both sides of the equation by negative 8. And this is going to give us that x is equal to positive 1. So let's put a comma here and just put a 1. So x can be equal to 0. Or also it could be 1. Okay, let's look at problem number 5. So this one's just a little bit more involved, but it goes back to the same concept that we looked at the first part of the video. And essentially you want to isolate the absolute value operation on one side and a single number on the other. So we have 8 minus 7 times the absolute value of 9x minus 2, and this is set equal to negative 6. So the first thing you would want to do here is subtract 8 away from each side. So let's go ahead and do that. And so this is going to cancel over here. And what you'll have is negative 7, and I'll put times the absolute value of 9x minus 2 is equal to, you have negative 6 minus 8, that's negative 14. Okay, so because this is multiplication here, you want to use division to undo it. Again, you're trying to isolate this guy right here. So since negative 7 is multiplying that, you're going to, again, just divide both sides by this negative 7 because it's multiplying. And so this guy right here is going to cancel. And you'll have your absolute value of 9x minus 2 isolated on the left-hand side. On the right-hand side, negative 14 divided by negative 7 is going to be positive 2. Okay, so now we have this set up into the absolute value operation on one side, a single number on the other. So hopefully you remember how to solve this. Essentially, you're going to drop the absolute value bars, and you're going to take this 9x minus 2, set it equal to 2. Then or, drop the absolute value bars, so 9x minus 2, set it equal to negative 2. So let's add 2 to both sides of the equation over here. This would cancel. You'll have 9x is equal to 4. Divide both sides of the equation by 9. You get x is equal to 4/9. Okay, then I'll put or. Over here, let's add 2 to both sides of the equation. This is going to cancel. We'll have 9x is equal to negative 2 plus 2 is 0. Divide both sides of the equation by 9. You're going to get x is equal to 0. Okay, so x could be 4/9 or x could be 0. Again, most people will just write this as x equals, let's put 0, 4/9. Okay, let's look at problem number 6, a similar setup to the last one. So what we're going to have here is 6 times the absolute value of 10x minus 1, then minus 4 is equal to 50. So again, I want to isolate the absolute value operation on one side, and I want a single number on the other. So let's deal with getting rid of this minus 4 here first. So let me add 4 to both sides of the equation. And so this would cancel. You'll have 6 times the absolute value of 10x minus 1 is equal to, this would be 54 here. And what I'm going to do is just divide both sides of the equation by 6, since 6 is multiplying this guy. So we'll cancel this with this. And now on the left-hand side, I have the absolute value of 10x minus 1 is equal to, on the right-hand side, 54 divided by 6 is going to be 9. So now that we have this in the format that we want to drop the absolute value bars. So I'll say 10x minus 1 and set it equal to 9. Then or, we want to drop the absolute value bar, so 10x minus 1, and set it equal to the negative of this number, so negative 9. So over here on the left, let's add 1 to both sides of the equation. You're going to get 10x is equal to 9 plus 1 is 10. Divide both sides by 10. And let me show this as canceling here. We'll get x is equal to 1. Then over here, let's add 1 to both sides of the equation. This would be 10x is equal to negative 9 plus 1 is going to be negative 8. Let's divide both sides of the equation by 10. Let's cancel this out. And I'll put my or here. And I'll say that x is equal to, we know this is negative. Let's write 8 as 4 times 2. Let's write 10 as 5 times 2. And let's cancel this common factor of 2 between numerator and denominator. So x equals negative 4/5 like this. So these are our two solutions. X could be equal to, let's put negative 4/5, and then you could put comma, positive 1. Okay, let's look at problem number 7. So here we have 9 plus 2 times the absolute value of 3x plus 7, and this is set equal to negative 37. So what I want to do again is isolate this part right here on one side, have a single number on the other. So let's subtract 9 away from each side of the equation. Then let's cancel this. I'll have 2 times the absolute value of 3x plus 7 is equal to negative 37 plus negative 9 is going to be negative 46. And then from here, I can just divide both sides by 2, and this would cancel. And I'll have the absolute value of 3x plus 7 is equal to negative 46 divided by 2 would be negative 23. Now, I don't need to continue here because, as I told you in the lesson, if you have the absolute value operation isolated on one side and you have a negative number on the other, it's impossible for you to get a solution, right? Because the absolute value operation makes things non-negative. So there's no such value that I can plug in for x here, multiplied by 3 and add to 7. When I take the absolute value of whatever that number is, whatever I can come up with, it's always going to either be 0 or some positive value. It can never, ever, ever be a negative 23, right? So this is not possible. So there is no solution here, okay? And some people like to write the symbol for the null or empty set. Again, we'll talk about this later on in the course. But if you ever get something that sets up this way to where the right side here is negative, again, once you've isolated the absolute value operation, you're not going to have a solution. If the right side was 0, then you would just have one single equation to solve. Okay, let's look at problem number 8. And here we have 4 times the absolute value of negative 3 minus 8x, then plus 2, and this is equal to 118. Okay, so again, just trying to isolate this absolute value operation here. So I'm going to subtract 2 away from each side of the equation. And let's cancel this. We have 4 times the absolute value of negative 3 minus 8x like this. And this equals 118 minus 2 would be 116. Let's divide each side of the equation by 4. Let's slide down here. And let me cancel this guy with this guy. We have the absolute value of negative 3 minus 8x is equal to 116 divided by 4 would be 29. So again, once I get to this setup here, all I need to do is drop the absolute value bars. And I'm going to actually reorder this a little bit. I'm going to put negative 8x minus 3. And then I'll set this equal to positive 29. Then or, I'll have negative 8x minus 3. I'll set this equal to negative 29. So I'm just going to solve these two equations, and let's see what we get. So let's add 3 to both sides of the equation over here. This would cancel. I'll have negative 8x is equal to 29 plus 3 is 32. And let's divide both sides of the equation by negative 8. We'll get x is equal to, this would be 32 divided by negative 8 is negative 4. Let me put or here. Over on this side, let's add 3 to both sides of the equation. Let's cancel this. If I do negative 29 plus 3, that's negative 26. So you're going to have negative 8x is equal to negative 26. Let's divide each side of the equation by negative 8. Let's show this is canceling here. We'll have x is equal to, let's write 26 as 13 times 2. Let's write 8 as 4 times 2. And so we're going to show this is canceling this 2 with this 2. So x would be 13/4 there. So let's put that like that. Or if you want, you can put x is equal to, let's go negative 4, comma 13/4. All right, let's look at problem number 9. So this one looks like it'll be a little bit tedious because of the fractions. We have negative 11 over 10, which is multiplied by, let me show that, multiplied by this absolute value of 3/2 x plus 5/2, then plus 4/5 is equal to negative 147 over 160. So I would start by clearing the denominators. So on the outside of the absolute value operation, and you think about the denominators out there, you have a 10, a 5, and 160. So you can just use 160 as your LCD. And so 160 times this guy right here, 160 divided by 10 is 16, and 16 times 11 is 176. Let me put negative 176 times the absolute value of, you have this 3/2 x plus 5/2, and then plus, if I go 160 divided by 5, that's 32, and 32 times 4 is 128, and this would be equal to, over here, this would be negative 147, because again, I'm multiplying by 160. Okay, so this is all set up. I don't have any fractions anywhere except for inside the absolute value bars, which we'll deal with later on. Let me slide down here. And again, my goal is just to isolate this for right now. So let's subtract 128 away from each side of the equation. And so this is going to cancel. And so what I'll have is negative 176 times the absolute value of 3/2 x, and then plus 5/2. And then that's canceled. So this equals, if I do negative 147 minus 128 in my calculator, I get negative 275. We have this negative 176 times the absolute value of 3/2 x plus 5/2. This is set equal to negative 275. So let's divide both sides of the equation by negative 176, like this. And so this is going to cancel. And we'll say that we have the absolute value of 3/2 x plus 5/2. And this is equal to, negative divided by negative is positive. So let's write 275. I'm actually going to write this as 5. I would start with 5 times 55, so it would be 5 times 5 times 11. And then for 176, I could do 16 times 11. So let me put 11 here times, you can put 16 or 2 to the 4th power if you want. It's really up to you. Let's just put 2 to the 4th power for right now. And we're going to cancel this common factor of 11. So this is going to be 25 over 16. So let's write that as 25 over 16. So from here, it's really not that bad. What I'm going to do is set what's inside of here equal to this, and then what's inside of here equal to the negative of this. So let's say that we have 3/2 x plus 5/2 is equal to 25 over 16. So for this equation, I can clear the fractions by multiplying everything by 16. So 16 divided by 2 is 8. So basically you would have 3x times 8, which is 24x. And then plus, again, 16 divided by 2 is 8. 8 times 5 is 40. And then this equals, obviously the denominator of 16 there would cancel. So this would set up the same for the next one. You would just go or, and this would be negative 25 instead of positive 25. Let me actually just erase this real quick. And then we'll say 24x plus 40 is equal to negative 25. And actually I should probably just do this over here so I can fit this all. So 24x plus 40 is equal to negative 25. All right, so now let's work on the one on the left. So let's subtract 40 away from each side of the equation. That's going to cancel. I'm going to have that 24x is equal to 25 minus 40 is going to be negative 15. And let's divide each side here by 24. And so I'm going to get x is equal to negative 15. Let's write that as 5 times 3. For 24, let's write that as 8 times 3. And we can see that we can cancel a common factor of 3 between numerator and denominator. So x here would be negative 5/8. So I'm actually just going to erase this and just put x equals negative 5/8 there. And then let me just drag this down here. So we have some room. I'll come back up and answer that completely in a minute. We know this is an or. We can get rid of that. So let's put minus 40 on each side here. Cancel this. We'll have 24x is equal to negative 25 minus 40 would be negative 65. And let's divide both sides of the equation by 24. Let's cancel this. X is equal to, we know this is negative. 65 is 13 times 5. And 24 is basically 8 times 3. So 2 cubed times 3. So no common factors here other than 1. So we're going to have to write this as negative 65 over 24 like this. So let's erase this. Let's put our answer, let's put comma, and we'll put negative 65 over 24. All right, let's look at problem number 10. Again, another tedious one because we have some fractions involved. So we have negative 4/5 times the absolute value of 3/2 x minus 28/9, then plus 8/5 is equal to 14 over 45. Okay, so thinking about the fractions on the outside of the absolute value bars, again, the LCD there, if you think about 5, 5, and 45, again, don't worry about what's inside the absolute value bars for right now. The LCD is going to be 45. So what I'm going to do is multiply both sides of the equation by 45. And so 45 divided by 5 would be 9. 9 times negative 4 is negative 36. So you'd have negative 36 times the absolute value of 3/2 x minus 28/9. And then plus, if I do 45 divided by 5, that's 9. 9 times 8 is 72. This equals, obviously, if I multiply this by 45, the denominator would cancel. So you just have 14. Okay, you slide down here. And now let me subtract 72 away from each side of the equation. Let's cancel this out. We'll have negative 36 over here on the left times the absolute value of, you have 3/2 x minus 28/9. And then this is equal to 14 minus 72 is negative 58. And then to finish this up, let's divide both sides of the equation by negative 36. And so this is going to cancel. And we'll have the absolute value of 3/2 x minus 28/9 is equal to, negative over negative is positive. For 58, it's 29 times 2. And then for 36, you can think about this as 6 times 6. And 6 is 3 times 2. So basically it's 2 squared and then multiplied by 3 squared. So what I'm going to do is cancel one of these 2's. So I'll cancel one of those with this. And so this would be 29 over 3 squared is 9 times 2 would be 18. So 29 over 18 would be the simplified fraction there. Let's put this like this. So 29 over 18. Okay, so let's set up our equations. So again, what's inside the absolute value bars? So we have 3/2 x minus 28/9 is equal to 29 over 18. Let's clear the fractions first, and then I'll do the compound equation with or. The LCD here would be 18. So if you multiply everything by 18, then 18 divided by 2 is 9. 9 times 3 is 27, so this is 27x. And then minus 18 divided by 9 is 2. 2 times 28 is 56. And this equals, obviously the 18 there would cancel, so you just have your 29. So let's erase this. And let's say or. We'll take the 27x minus 56. Set this equal to now negative 29. Okay, so let's solve these two equations. Really not that bad. So we will add 56 to both sides of the equation. This would cancel. You'd have 27x is equal to 29 plus 56 would give me 85. And then I would divide both sides of the equation by 27. And so this is going to cancel. We'll have x is equal to, for 85, it's 17 times 5, and 27 is 3 cubed. So there's no common factors other than 1. So we just have to leave it in this format. Let me make the 5 a little bit better there. Now let me solve this one. I'm just going to get rid of this. We know it's an or. Let me move this over here. And we'll come back up and list the solution in a moment. Let's add 56 to both sides of the equation. And let's get rid of this. We'll say 27x is equal to negative 29 plus 56 is 27. And then let's divide both sides of the equation by 27. Let me slide down here. And let's cancel this with this. We get x is equal to 1. And let's just put a comma here and put a 1 here. So x is equal to 85 over 27. And then also it could be 1.